Let's carry on here. So you got to make a plan for eradication action. You're going to plan. It might take you a while to make a plan, but you're going to plan to do it quickly. And so you're going to have a single event that will completely recover you from the compromise. That's what you try to accomplish. So all of their access is gone, and therefore you are relying on the investigation team to have actually found all the pieces of malware and backdoors and channels of control that are being used. If they didn't, then you're going to fail. So the goal is to remove their entire access to the environment, deny them all their access to your systems and data, remove the attack vector so that the attacks they're using cannot be repeated, and therefore make people so they trust their system again. They feel okay about working in your customers, trust it, and everybody believes you that you've really kicked them out. You can expect them, of course, to try to come back in. You are going to have to monitor and watch for attempts. They will probably try to find other vulnerabilities, then they may perform aggressive actions in retribution if they have the ability to do that. This is what you can expect after eradication. So common eradication actions: disconnecting the organization from the internet during the eradication event. This is probably the optimal situation. Take everything completely off the internet. Now we know they're gone. Now re-image everything, change all the firewall rules, update everything, then connect, and now they're out and they can't get back in. That would be nice. In reality, you can't really do that as perfectly as you like. But then you block IP addresses, sync all domain names, change all the passwords, segment the network, mitigate the vulnerability, rebuild the compromised systems, and then when you reconnect to the internet, you've got a fresh, clean company. And this, of course, is the ideal case that would only work for a small company. It'd be nice to do this on a weekend so that the disruption you're causing in business will be minimal if you don't have business happening on the weekend. This is one thing I always saw in all the Mandia reports of the APT threats is they would log their working hours. And I thought the point of that was to figure out what nation they were in, but this is something I hadn't thought of. You can plan to do it when they are asleep, which gives you more time before they will wake up and realize that you're kicking them out and do something about it. They may very well recompromise you during eradication. If they aren't asleep, they will notice you're kicking them out and immediately attack you before you're done with the eradication effort. So you would either have to try and contain the recompromise or investigate in parallel and start another investigation of the second attack and have another whole process. It depends on what happens. That's what I mean. This is combat. That's why this field is interesting. You have an intelligent attacker. All your plans are going to be thwarted by their intelligence, and you'll have to adapt them. So another response, if you find that they've recompromised you, is during the eradication event and try again later. And this is something you would do if their attempt to recompromise you is so successful that you're totally hosed again. You say, well, we just have to give up and do it all over again, which is going to make management really love you when you have to spend all this money again, but that's the way it is. The eradication plan is in principle pretty easy to design because there's really only a few things you can do. Rebuild, for one system, you rebuild from known media or you clean off the malware. The second is vastly inferior, as anyone should know even from normal tech support, because cleaning malware is a pretty risky business. You never really know you got it all. But that's what people usually like to do because then you don't have to bother rebuilding the whole system and they don't really have proper backups. Your company hopefully has proper backups and it's relatively easy to rebuild the system. If not, you might as well get used to it, and that would be your long-term strategy. Improve your stinking backups so you have a deployment server ready to just deploy the image quickly so we don't have to do nonsense like trying to clean malware off. Yeah?
Can you basically on the side build the new server networks?
Yeah.
And that way, when you're doing the shutdown, you have that ready, and then as you're going around cleaning individual workstations that actual people use, then they're all allowed to attach to the new.
That would be good if you can do it. Large organizations might have so many servers that that's not really practical, but yeah, just switching over to a parallel system is not a bad plan at all if you have that option. So if you have compromised credentials, the obvious thing is change the password. Another thing is to delete the account and issue a new one. Those are typically the main things you're going to do. The main reason you fail is because you did not plan correctly, so you get halfway through and discover something is not working, like you really are unwilling to take these systems off the internet, and therefore you fail. You generally can't take the whole company off the internet. Very few companies can actually tolerate that. I remember 15 years ago, my escrow agency, we totally did that. The I Love You worm came out, and they called me on the phone and they said, pull the plugs out of all the modems. Our whole company had 5 dial-up modems. That was the whole internet. And I pulled out the plugs and we were off the internet for 3 days. And it worked because we really didn't need the internet. Our business was mostly mail and fax and telephone calls. But in these days, I don't think that very many businesses can survive without the internet. If you're going to let some people continue to be on the internet, then you're going to have to make sure that these business critical systems are limited in what they can reach. And you're going to have to keep connectivity between your geographic sites so your IT teams can coordinate. And your business-to-business communication, like your partners and trusted other locations, you're going to have to decide on a case-by-case basis which ones of those you have to keep up, and that's a problem. You be aware of side channels. One of the split VPNs is a common problem. If you go to Starbucks and you connect to the Starbucks Wi-Fi and then you connect to your corporate VPN, if your VPN is not configured correctly, you are now a leak of the internet into the company through your VPN. That's why the correct way to integrate, which is never popular, is that if I go to Starbucks and connect through the VPN, now all my internet traffic has to go through the VPN. So if I want to go to a website, I go to inside the company, out through their firewall to there, and that means I'm subject to all the filtering at the company. And it's slower, but it's a whole lot safer than having me go directly to the internet and inside the company. Now I'm a hole. Things can leak in through. Anyway, if you're going to connect things, make sure they're clean before they connect. These are all goals. I can see why this often fails, because you need cooperation of your business partners and vendors and everybody. In a big company, there'll be a bunch of people that don't really cooperate like they should. Even changing passwords is a big hassle. You've got Windows, Linux, and Mac user accounts. You have service accounts. Like devices make calls periodically to like download email and stuff. There's a bunch of processes going on that are not humans, but they have login accounts, and those accounts can be used by bad guys. You have local accounts on Windows systems in addition to domain accounts. So there's a local password hash and a local account that lets you install software on the machine, and there's a domain account that lets you move from machine to machine, and you have to consider them both. And the problem is the local account cannot be changed from a central location, not easily, like the domain account. All right, you got your Active Directory, which one place that's fairly easy to change. Then you got applications that have accounts, and you got networking gear that has accounts, SNMP passwords and login passwords to your routers and switches and stuff, and your databases have passwords. And the real problem with them is not only do you have to change them one by one on those systems, but you have people writing apps with hard-coded passwords in the apps, and you don't even know how many people have done that. And so when you change the password, a bunch of things will quit working that you didn't expect. And you have to hunt all that junk down. And this is part of why your long-term strategy will be to get more organized here, so we actually don't hard code passwords in apps, but we have some central management of that. All right, that's the point. Forcing a password reset of users is easy. Like every time you reach, they say you have to change your password. The problem is the person who gets that notice might be the bad guy. So they change the password, they're still in. This is actually kind of a problem. And so there are ways around that, but it gets more expensive. You could generate random passwords and send them through some trusted channel to all your users, like mail it to them all, email them. Then only if they got in that person's email account would they get it. You could make everybody call the help desk and verify their identity to get in, to change the password. That's, again, expensive, but this will be harder for the bad guy to duplicate. Then your service accounts. Like I said, this is a drag. These are automated processes from one machine, fetching data from another machine, which is happening all over the place. And when you change the password on every system and the central directory, then you're going to randomly break things in the company that used some unexpected way of authenticating, and you'll have to be aware of that. Changing all the local administrator passwords to something unique is difficult. The whole point of local accounts is they're not controlled by the domain controller, so you're going to have to do something. Why it's very common for people to use the same local administrator password for every account. This makes it easy to have a script that will do something like collect all the events from every machine, but it also is risky. So it'd be better to have, the most mature system is to have a randomly generated different administrator password in every system and some central vault, which people are checking out passwords and checking them back in as they use them, like enterprise level password manager. But of course, that's a pain to set up. But that would be a lot nicer if you have it, a lot safer. In the meantime, a lot of people do it by writing scripts to change all the passwords in some spreadsheet with all the passwords that someone's keeping track of. And all the enterprise level password manager is a more automated, more professional version of that. So now the next thing is you've got machines and they have data on them. You can't just rebuild them from zero. You have to take the data off them then rebuild it, then put the data back on it, especially the end user devices. So now you might be getting the malware off them and putting the malware back on them. So it's a problem. So it's a good idea to also block malicious IP addresses and black hole domain names, so that if you do put the malware back on there and it tries to run again, it will have trouble phoning home because your network no longer lets it reach the command and control servers. Here's common complications. You have users who are traveling and don't change their password in the time. You've got accounts that are no longer active but were never disabled, so you send out notifications and nobody's reading them and you don't know that. You've got systems that do not belong to the domain, so your domain changes don't reach them. You've got local user accounts that are not the administrator account but have administrative rights. So more administrator accounts than you think you have, so you're not really changing all the passwords. These are very common problems. All right. And it's expensive and complicated to really track this well enough. Like at this college, part of that virus scare, the one grain of truth was there was one lab where someone took the antivirus off the machines, and we didn't know that happened because we didn't have a central monitoring of the antivirus on the machines. So you could have the local administrator turn off the antivirus and we would not know. And that's an issue. So you could have some clown making local administrator accounts and you won't know if you don't have a central system monitoring that, and that's expensive and hard to set up. So anyway. All right. So which one of these comes from the investigation team? Quit at 25. All right. They give you the scope. They tell you what machines are involved, which passwords have to be changed, and all that. If they're wrong about the scope, your eradication will fail. All right. What's the easiest passwords to change? Quit at 25. All right, and that's Active Directory. That is the whole point of it, is your central point of administration. Local accounts are very difficult to change because you have to do them one by one on every system. And you can only do it after authenticating with an administrator account on each one to do them. The whole point of Active Directory is you have one database and you just change it right there and that's it. Nobody can log in. That's why you do it. Yeah.
Why don't database accounts?
Because if you change the database password, you very frequently find that it has to be changed in all kinds of other places that you don't know about.
Other clients?
Like everybody's custom software with hard-coded credentials in their SQL queries. That's the problem. But Active Directory, the whole point is there is just one place, and every time anybody authenticates, it goes to that ID server to get it. So when you change it there, it's really changed, and that's it. And if you use the new password, it'll work everywhere. That's what it's for.
But don't you have, what do you mean by Active Directory account? Is that the users?
Yeah, you can have other accounts. Users and processes both can be in Active Directory, so they're on the domain controller. And if you change it there, it has an immediate effect. And it's the same everywhere too. So you don't have to go hunting around for it. There's just one central point of authentication.
Sort of like LDAP.
It is LDAP. And that's why you use Active Directory, because it frees you from this madness of trying to touch every workstation to solve a problem. You have one central point where you can change something and it affects the whole company.
Okay.
Yeah, good. All right. So which one of these is most likely to reintroduce malware into the system? All right. And of course, putting on the old data is risky. All right. So now you're going to determine the timing of the eradication event and execute the eradication event. If you eradicate too early, then your investigation team has not yet determined the scope, and you will fail because you won't really end all of the bad guys' access, like some backdoors you didn't find. If you wait too late, they will finish stealing what they came to steal, and now you not kicked them out, but it doesn't really matter because you've already suffered the damage you were trying to prevent. The ideal time is what they call the strike zone. This is the point when they are still preparing to do the damage, but you figured out what's going on enough to stop them. And it is more of an art than a science to determine when you made it here. But you want to find when the investigation team has found enough about their tools, tactics, and procedures so you can efficiently kick them out. There's the plan. Too early is down here where it's beginning, and if you kick them out, they'll just come back. The strike zone is here, and it's too late here because they're already done and bored, and they don't really care if you kick them out at that point because they've done the job. So here's indicators. When the investigation team feels like they really understand what's going on, they have good visibility in the environment, they understand their tools, when they are not finding any more compromised systems per day. That has slowed down. That means you're wasting your time doing more investigation. When you're not finding any new indicators of compromise, you're just finding more of the same, then again, there's no point continuing because you're not learning anymore. And your remediation effort is thoroughly planned, you're ready to go, then there's no point waiting. So you have to agree on this by the incident owner, the investigation owner, and the remediation owner. These are the people ultimately responsible for these things, and they have to agree, now is the time we're going to do the event. All right. When you plan this, they say you will never really be ready. Everyone will always want more time to get ready. But so you have to just push them. So he said what you should do is choose a date that is a little difficult for everyone to achieve to push them. And don't let them delay the date, because once they start delaying it, waiting for something, then they'll just keep delaying it forever. Here's a typical sample eradication event. You disconnect from the internet. Now you change your access control lists and your DNS settings to black hole and unblock the malicious IPs, remove the compromised systems and rebuild them, change all the passwords, and then verify that all these things have happened, which is really important because when you think you've changed all the passwords, you probably haven't really changed all the passwords. And when you think you have blocked certain IP addresses, you probably haven't really blocked access to those IP addresses from every segment of the network, not until you check. And then you connect them back in. So you test your network connections. The way to do it is go to each network segment and browse the legitimate websites, try to FTP, attempt to access the addresses, from all locations that have their own IP addresses, because those are ones that could be remotely controlled. Don't test from all your segments, your logical segments, your geographic segments. You can't just ping and decide because a ping fails it's not connected. You got to use something smarter like Netcat or Nmap that will really try various ports to make sure that you block what matters. And you should also add alerts so that if any traffic does go to those forbidden addresses, you'll be informed about it. Yeah?
Oh, no, sorry, there's
That's right. Okay, yeah. Okay, all right, so then you're going to remediate the compromised systems. You can rebuild it or remove malware. When you're storing data, make sure you're not reintroducing malware. Cleaning is for amateurs. Cleaning malware off a system, because if you run some kind of scanner and you find malware and you take it off, you have no reason to believe there isn't more malware that the scanner didn't detect. So this is pretty foolish. It's much better to just rebuild from known clean media, and there really is no excuse for not doing that if you have any proper reasonable backup strategies. If you feel like you have to clean the malware off, that usually means you are running a pretty slipshod shop and not using professional ways of backing up your stuff. However, there may be some cases in which you have to, where you have just a vast number of infected machines. It would be far too expensive to rebuild them all, and so you're willing to accept the less perfect solution of running some kind of script that removes the malware from them, and you're willing to tolerate the possibility that some of it is left on there. All right, so once the compromised systems are offline, you start changing passwords, and this can be proceeding while other systems are being rebuilt. You start early because the password change is the hardest thing, because you will almost always find that you think you changed all the passwords and there's a problem that prevents you from really doing that. Then you have to verify that things are successful. It is very common that some of the systems are overlooked, not really rebuilt, or not rebuilt at all. Some local administrators on your team will frequently decide to just remove malware instead of rebuilding the system because they feel like it's too much work, or they haven't really been doing their backups like they were supposed to and they would prefer not to admit that, or other reasons. They will just do what seems good enough to them and ignore their instructions if you don't audit them to make sure they really did what you tell them to do. So those systems may still have indicators of compromise, like registry entries or configuration files. You got to verify that all the passwords were changed. It is, of course, the easy way is to just make all the passwords expire in Active Directory, then you know they've changed. But the other ones that are not in Active Directory, you're going to have to verify them by sort of probing one by one or writing scripts that probe. You need to communicate during the event. all the administrators all over the place need to know when it's time to do the next item. You will almost always have problems you did not anticipate, where you change passwords and some business critical thing stops working, and now you have to find out why did that happen and what am I going to do about it. So here's common strategies. You can have periodic meetings where people have to come together several times a day and get the phone in so we talk about how it's going, or you can have some kind of bridge open continuously. I know our competition team is arguing about this, where if you're using Slack or what are you going to use to make sure everyone knows what to do, it is a problem. And it's exactly the same kind of issue. I know at Microsoft, every workstation has 2 monitors, and 1 monitor is required to have Outlook open showing your email at all times, and they use email for this. If they send you an email, you can't say, I didn't read my email for an hour. You say, you are supposed to have it open and notice when one comes in. That's how, you have to have some scheme of how you can reach people. All right, your eradication team includes more people than the remediation team, because you're going to need to do a whole lot of work. So you're going to have all kinds of people called into image servers and change passwords and change access control lists. Everybody is going to be doing things, and which is probably another reason why you will typically find it's not really done correctly and thoroughly, because you're calling in all these other people who are probably less reliable. And when you're done, it is really important to inform your help desk so your help desk can quickly contact the eradication team, because you have probably now broken things you don't know. And when people try to do business in the next week, they're going to discover that something doesn't work anymore because you changed all those passwords and access control lists, and it needs to reach you so you can figure out what to do about it. Yeah?
Is there any point of finding that attacker's IP address?
No. Almost the only person, I was at the Secret Service event, and the representatives of a major antivirus and security company were up there saying, threat intelligence of that kind is useless. It's no point in knowing who attacked you. And then the Secret Service guys stood up and said, well, you know, we guys in law enforcement are the ones that care who attacked you. They are the only ones that care. If you're law enforcement, then maybe you care, because you might actually think you can prosecute that guy, but everybody else is just a waste of your time. It doesn't matter if it's Americans or Chinese or Japanese or anybody hacking you. You just got to kick them out, whoever they are. And as far as hunting them down and punching them in the face, that's really not going to do any good anyway. You just want to kick them out.
For litigation purposes.
Yeah, but even suing them is usually hopeless. They've usually in a foreign country or something, and they probably don't have any money to take. It's usually all that effort is a waste of time. The only thing that is really efficient is to protect your own network, kick them out, improve your security. Then you can do your business, make money that way. There are a few people that want to hack back and hunt them down, and this is mostly counterproductive. I don't see anybody make a realistic business case for how it would really benefit my company to hunt down who hacked us. The only people that have any motivation to do that are law enforcement. But we aren't the cops, and there's no point trying to hunt them down. It's very hard to hunt them down, and even if you do, that's not going to solve your problem, because if you haven't done all these remediation steps, some other clown will attack you the same way. So anyway, that's a good question. A lot of people argue about this, and it's quite fashionable to hack back and all this stuff. There's a bunch of people selling books and doing classes about it, but I think it's mostly emotional. It makes you feel good to feel like you've taken revenge, but it's not really a practical business plan. All right, so then you got your recommendations. So once you have done your eradication event and this incident is now over, now you can pass up to management your strategic recommendations, how you should improve this place so you don't get hacked again. And so these are things that are difficult and disruptive, just like after a pen test, we talked about, you want to have recommendations of what you should do. So it's things like upgrading to a more secure OS, reducing user privileges throughout the environment. You find out a bunch of people running as administrator, segmenting your network, filtering outgoing traffic. These are good things that you should do, but they'll take time to set up. So again, you just describe these from a high level only. You don't need to get into details, because these are plans for the future. Document them all, even if you don't think they're willing to implement them. You want them all to be considered, and then you can put them in order of priority. Figure out what is going to do the most benefit and put that first, and have them all on there. One thing not mentioned in the book, which I know is certainly true of the students of mine that are working in this field, is that you want to make sure you put everything on the paper so that they don't come after you later for failing to warn them about something. It protects you when you say, well, I told you. That's an issue. If, for example, they are ignoring your recommendations and doing a slipshod job and you say, I warned you, You can't claim that I'm the one that didn't fix that. Anyway, so then you have lessons learned for major efforts, of course. Small efforts like building an individual system, you probably don't have one. But in general, you're going to have lessons learned, and you should have something like a wiki, which you can search, where you store these things online. It should be easily searchable and browsable so that you can keep a record of all the things you did. You may be writing custom scripts to change all the passwords, something like redline being used to harvest the data and indicators of compromise, and techniques you use to do things, arguments you use to convince management to spend the money. All that stuff is stuff you're going to need next time too, and you'll wish you had saved it. All right, and how to determine all the service accounts and so on, how to find all the scripts and applications with hard-coded passwords. Once you figure out how to do that, you should really record that so you don't have to try to figure it out again next time. Just identifying all your systems and how you convinced management to comply and how you convinced users to comply. These are all useful things. You'll want those for the next incident. Document them quickly. Tell everyone in the remediation team this is part of the job. You must do this. Don't let them put it off for a few weeks, or they will just lose all the data and you won't be able to gather it up again. All right, and of course, this lessons learned database is confidential. This contains all your security problems, all your scripts, all your policies, stuff you don't want the attacker finding, so you don't just put it on a public website. It's got to be available to your remediation team, but not to the general public. All right, I got some eye clickers, and I think that's the end of it. Good. All right. So, which one's a tool to test networking? I don't know. I'll quit at 25. All right, that's NetCat. Good. All right. So, which act increases the risk of incomplete eradication? Quit at 25. All right, obviously, going too early means you're more likely to not know the scope and fail to really kick them out entirely. All right, which action is most likely to fail? Quit at 25. Okay. All right. And like I say, cleaning malware from the system is largely an exercise in self-deception. Yeah.
How can you do B? Is B possible based on the question I was asked over there?
Well, blocking IP addresses?
Yeah.
Oh, that works fine. It's usually quite easy.
You don't know the target IP.
That's true, but it's reasonably doable to find the malicious IPs and block them. What's almost impossible is to remove malware and really make sure you got rid of it. That's why this one, all these have some chance of failure, but this one has a high chance of failure. That's why it's really an unprofessional thing to do. The rest of these, you really have to do. All right. And, all right, which one of these should be a wiki?
Sounds like several of them should be a wiki.
You could, but I think there's a best answer. I'll quit at 25. However, arguments are always an option. All right, but the lessons learned is the one they talk about. Lessons learned in particular should be a wiki, so it's easily alterable and searchable. The rest of these could be done that way, but more likely are going to be done other ways. All right, so I'll just see who got the most right. Let me stop the recording, and I'll go to the lab and help anybody who wants help there. This is 121, Chapter 17B.